I started my PhD many years ago, focusing on remote cameras, surveillance cameras. And, it's a very important area of research for security purposes. But the moment I started looking at footage coming from these wearable cameras, I realized the big shift that I wanted to do in my research. So more than 13 years ago, I started a research lab focusing purely on understanding behavior from wearable cameras, from egocentric vision. We looked through all aspects of industrial setups, humans at home, interactions between people. So we've been working on understanding actions, anticipating actions, so predicting what the person is going to do next in the future, which is a very interesting topic from an egocentric perspective. Also understanding how humans change the world, because we go around, opening stuff, moving stuff, changing the world around us to achieve goals. Understanding humans' goals and when do they feel that their goal has been achieved versus they failed to achieve their goal. Understanding skill. How do we know that someone is more skilled than someone else in a task? And accordingly, how can we teach someone how to improve their skills? All these things we do naturally. The question is, can agents or intelligent agents or machines improve in performing such a task, which is extremely simple for humans. Humans can watch footage and say, oh, I see this person chopping a tomato, and indeed they know what they're doing better. And it's very difficult to put that into words, but visually it's a very clear signal, the ability of people to perform tasks, the ability of people to use tools. So over generations, people have moved from the ability of knowing that their hands have limitations. We can't cut things with our hands. We have, there are limited capabilities despite the fact that our hands are very versatile, we have invented tools that enable us to extend our hands' abilities. So we've done a lot of work on understanding the variations between tools and how humans pick the right tools for different tasks. One of the recent researchers that we put up a paper in a conference called ICCV was about understanding the cutting action. How do you choose that if you're cutting paper, it's a set of scissors, but we still use scissors to cut bags, but we can also cut bags with our hand, and how all these variations differ. And again, especially for imitation learning for robots, if we can map this understanding of objects, tools, and goals, then that will enable future capabilities. So as a lab, we've been interested in understanding hand-object interactions, but also understanding the audiovisual signal coming from an egocentric camera. The camera travels with you to the action. So if you're opening a tap, you're there along with the audiovisual signal, capturing the sound of water, capturing how you actually perform. Sometimes some of the signals are clearer from audio than from video, especially if you're washing or rubbing something. But not every action has the same level of audio. Some actions are silent. You can perform something visually and you can't hear anything from an audio perspective. Sometimes you hear the audio, but it's ambiguous. How can you combine these audiovisual signals to understand, again, hands, tools, objects, and environments is what my research lab has focused on. We are a group of 12 people, so I lead the group as the professor, but there are brilliant researchers around, all focusing on various aspects of understanding human behavior from an egocentric. It's well understood that gaze primes action. So before you want to pick an object, the first thing you do is you look at it. You look at the object and then you extend the hand. And sometimes when you actually hold the object, your gaze has already moved, especially if it's something that is not gonna drop, right? At other times, when you're performing a very fine-grained action, you really keep your gaze fixed at the point you're performing the action. So the interplay between gaze and hands is an intrinsic, important component in understanding human behavior. The ability of gaze to prime actions, to also understand what people are thinking about while they're doing an action. You might, gaze at the oven to see if you know how things are going and coming back. And for years, we didn't have good technology, good hardware that can capture gaze reliably from different people. Gaze calibration has been a very difficult topic, and synchronized gaze approaches, so that's something that gives you accurate positioning of where you're looking when you're looking, was not available before. Devices like Aria enabled the capability of giving very accurate gaze by having these cameras looking at the human, at the two eyes, and anticipating exactly where you're looking. And by incorporating gaze into what we're talking about, which is the ability to understand people's goals, gaze is such a prime and important signal that enables our understanding. And without having the gaze signal, we're missing a lot in understanding intentions and actions and anticipating these actions. So for the past 10 years, we have been working in the area of egocentric vision. And my group at Bristol, we're really focusing on egocentric vision. That's the main research we do. We don't focus on other tasks because it's such an important and promising direction. And increasingly now, the area has completely changed. And it changed thanks to the efforts of researchers like us and others who have showcased the potential, the importance of this technology. The research has changed because more people are coming to understand other aspects maybe we haven't looked at, like social behavior, how people interact with one another, the difference between an observer who is having a wearable camera and the actor, the interplay between what we call the first person, the person carrying out the action, and a second view, which is the person you're interacting with. Imagine you're handing something to someone. These two cameras, the ability to have footage of these two cameras, is enabling approaches not only understanding social, but potentially towards human-robot interaction, which is this area of research is struggling to become natural because we haven't before managed to capture the interplay between humans, which wearable devices like Aria are enabling us to do due to the interesting synchrony that the team has successfully achieved, that you can synchronize a number of devices, time synchrony, and exactly have this ability to see how people interplay. So talking about gaze, for example, being able to have two people, knowing exactly the moment someone notices that you're handing something to someone, the attention, how they act, how they wait for the other person, the moment at which they actually exchange an object, and then how they naturally go into performing their daily tasks. Humans are social creatures. We don't do things on our own. And in egocentric vision, we were not able to do this type of understanding because we didn't have synchronized egocentric devices. So I think the potential is huge. That's one aspect. But the other aspect is robotics and imitation learning. Now, footage from egocentric cameras are becoming the norm to what we call pre-train or prepare devices that then the robot understands by watching lots of footage of people doing stuff, and then they only need a simple prime, maybe a simple thing like open this box, but because they've watched lots of these egocentric recordings, they can now replicate the action successfully. And the field of robotics is becoming more and more interested in egocentric vision. I would guess, I don't know how the field has grown in size, but the number of researchers starting their PhD on egocentric vision is probably doubling every year because of the potential of really the devices in the future. I say now we are stuck to these handheld devices, i.e. mobile phones. These are the current present technology, but imagine if your hands are free again, but you still are connected to your friends and to the technology that you want, but you have your hands back. For the past 10 years, the whole generation, their hands are stuck to these mobile devices, and we are all waiting to be freed of this handheld technology by having the wearable technology that satisfies our needs of connectivity, but at the same time, we can perform naturally our daily tasks. So before having Aria devices, which is a very nice form factor, well-engineered, and easy to use for non-technology-enabled people. You can just give it to anyone, and the setup to actually put it and record footage is quite intuitive. Before that, we were restricted in the number of people we could recruit. If someone is not technologically able, we were like telling them, oh, we're sorry, because there are like 20 steps you need to do to put something up, make sure you can view the right footage. And so we were very restricted in whom we can give the devices for, particularly for the unscripted recordings. We were interested in recording people in their homes or in their environments without the researchers being around, assisting them in using these devices. Also, lots of the things we could collect, we had to throw such footage away because they were not capturing the right setup. They were the wrong viewpoint, very dark. So lots of the footage we were interested in, we put the effort in collecting, but we had to throw the footage away because it wasn't capturing the actual hand-object interactions or people interactions. What Aria offered is something we can just a box, we can give it to people, very few set of instructions, and they feel more comfortable wearing it because it's a glass, it's just a set of glasses, and everything is nicely integrated. Even the cameras looking into the eye, the cameras looking outside, the array of microphones. Before that, we had like maybe 50 different things that we had to put to achieve the same thing. And now it's not only a single form factor, but it comes with our ability to just plug a wire, download all these time synchronized sensors that enable us to do things, not only very naturally, but open things that we were not able to do before. For example, we never had the ability before to do this spatial audio understanding from the array of microphones that Aria offers. So we have just done a pilot a few months ago where we gave 12 different people Aria devices. We asked them to record, hours during their day, and they were just able to put the cameras up. And their feedback was quite promising that we can now scale into, different people giving them the devices. They felt comfortable, sometimes too comfortable. We're like, are you sure you want to show your password to the camera? But Aria comes with all this ability to view the footage, so we can kind of remove any privacy concerns. It comes with all these technology like the Ego Blur that blurs, other passerby footage. We used to spend months looking at the footage and doing this de-blurring before. So the team comes with a huge background in egocentric vision, the actual research team at Aria. So they know what we need, and they're slowly bringing new technology that is assisting us every day. So Aria gives an array of sensors. It enables you to know where the person is in an environment. It builds this map of the environment so we can track the person going around. It's moving from this limited partial egocentric view to a world view. So you know where the person is moving around their environment. And particularly indoors, people go around their environment because they know, the fridge is here, the oven is here, my, sofa is here, the TV is there. We have this map of the environment. Before technology like Aria, we were able to build some rough estimates of environments, but they were not reliable enough. Now, Aria comes with this by default. So as soon as you collect the Aria device, you can use the machine perception tools that the team had made available to researchers, and we can plug this 3D understanding of the world. So that's one thing that Aria definitely enables. The other is this spatial array of microphones, giving you a spatial audio, so you know whether the sound is in view or around you. And before that, we were not able to do this sound separation, understanding where the sound is coming from. We were making educated guesses. So if someone hears a sound and they turn around, we know that the sound wasn't in view. But now we have the ability using the sensors. It also comes with other particular sensors like speed of head motion, and importantly, gaze. So it actually knows exactly where you're looking at, and all of that at a very high, what we call frame rate. So it's very accurate time-wise, and all these sensors are time synchronized. So we can reliably look at all these sensors. We were able sometimes to synchronize one or two of these things, but I don't think before Aria we were able to have a time synchrony of all these sensors. So, researchers are looking into, as I said, spatial audio, 3D understanding, gaze, both far gaze when you look further in the future, as well as close gaze as people focus on fine-grained understanding of actions. And as I said, it comes with this ego blur thing. So if you're recording others, if there is someone passing by, sometimes we used to throw this footage because we did not have consent. And at the moment, we can automatically anonymize this footage. So we can still use it, of course, up to our knowledge. We blur what we can blur, like faces, number plates. But we also look at the footage and check that people are happy with collecting all the devices so they can, and people are very happy to share stuff for research. They understand the potential of helping everyone, which is what we say is this technology should help everyone perform their tasks better. So it's not a selective set of people. And that's why doing research in universities is basically for the people. We publish everything we do, and hopefully it will change research. We don't know when, but it will change the way we do our lives in the future. Dynamic object locations is the task of understanding where objects are as you move them, right? And how they move around the environment, how you interact between two objects. Imagine the very simple task of you wanting to prepare a toast, right? So how do you do that? You kind of open the bag, get a toast, put it in the toaster. But while this is happening, you're prepping, right? You're bringing maybe the chopping board, picking a knife up, and these are coming into this common space, right? We can imagine this, but now we can actually model this. We can model how people bring objects. They bring the butter, they put the thing, and then they send this back to its location, sometimes not back to its location. Sometimes it stays that indefinitely, right? Until maybe the next time you're gonna put toast on the bread. But when people move around, bringing objects together to perform tasks, then putting them back, this is what we call dynamic object tracking or dynamic object understanding. And this idea of modeling where things are, as well as we have a new research, we're calling it out of sight is not out of mind. You still know where objects are as you put them away. And until now, research in computer vision hasn't tackled that at all. If I go to open a cupboard, I'm guessing a cupboard can have this or that. But now we know what you've put there. We've kept it in mind. And now we know as you're approaching what you are attempting to do. Anticipating human behavior becomes more interesting. If you're approaching that cupboard, I know this is the spices cupboard. So I know you're probably kind of going into picking up your spices. What if I can, think about, suggesting some spices based on the recipe you've been cooking to date? So the potential of full understanding of dynamic object interactions, leaving them in locations, but also reminding people where they've left something. This is research that we've always said. We've promised in Egocentric Vision that we will remind you where you've put your keys, right? That you don't need to search anymore because this device will tell you where you've put your keys. And while there is a limited set of questions we've asked before, now we're asking where everything is all the time. Where did you leave your spice? Where did you put this object? And how do you move around? And perhaps we will, tell people how messy they are and teach them how they can become a little bit more organized. Or if they would like to become more organized, if that is a goal they wish to achieve, how these devices can help you achieve such goal. There are many reasons why spatial audio is interesting. One is disambiguating what the person is doing. Sometimes you're holding an object in your hand and it's very small, the camera isn't seeing it, and the audio can give you a very good understanding of its material. So that's the aspect we're interested in. But there are many people interested in sound source separation. If you're doing the same action, but you're having the TV on or you have someone talking, how can I separate the sources of sounds and understand them independently? Because audio is a single 1D signal. And by adding a bit of spatial understanding, you can decipher this 1D signal and understand the distance between the camera and the source of the sound. And so sound tone separation become a lot more capable when you know the distances to the various sources. You also can know how you move towards a source. So if I move in a certain direction, I can now understand that I'm moving towards the source of the sound. If I'm picking an alarm or I'm picking, I can, and of course I can then advise people on safety concerns if they're going towards a source of sound or away from a source of sound. But many others are telling you that audio is the signal you can keep on all the time. Audio is a cheap signal to collect. Video is typically very expensive. We know that if you record audio on your phone versus video. Video is a very big file that occupies a lot of space, and audio is very lightweight. So there is interesting research in efficient understanding from audio primarily to only focus on when we need to collect video. And that's, again, another interesting area of research. We have big promises to people that AI will change their lives, right? I don't think we are, yet tackling such a promise. What does change my life mean? We've written a paper recently called An Outlook into the Future of Egocentric Vision. We know some potential applications. What if I go around a site in the world and some device can tell me about its history? They can see what I'm looking at and say, what is this? And it will kind of give me an understanding of the environment. So this 3D understanding with spatial audio, with gaze, can give you lots of interactions in new environments. But we also think it can give you lots of interactions in your natural environment, where I can observe people for very long doing the same task, and I can check with them what is their goal, maybe become healthier. What if you can then observe whether actually they're going in the right direction or not? What if their goal is to become more efficient? What if their goal is to capture some footage so their friends in another environment can replicate the task? What if we can, I think we worked on this research called You Do, I Learn. What if we can pass knowledge of humans? There is huge potential, but that potential cannot be delivered until we can understand what this footage is capturing. So we're currently at the perception level, which is understanding. And after understanding is done, we can do lots of things. Currently, there is generative technology that can, take this footage and generate new examples to, scale what we're capturing into new environments. What if you would like to imagine how you would cook in your new kitchen that you haven't yet moved to? If we can combine a new environment with your preferences, and you can then move around new environments and tell you, oh, you're not gonna like this place in advance. The potential is huge, but we're still at the level of perception. And technology that has multi-sensors like Aria is enable us to do deeper perception, hopefully towards larger applications. So the two words are egocentric versus exocentric. Exocentric is observing someone doing a task from a remote camera. So you're looking at the person, and typically you can see what they do if they're doing a big motion. But if they're doing an intricate detail, you probably are what you see is very occluded, and you can't see what they're doing specifically. So if you focus on how they interact with objects, that is not well captured typically from an exocentric perspective. An egocentric perspective is a view that is very similar to what you can see. So it's within your field of view. It doesn't capture your body, though you can estimate what the body is from an egocentric, but it doesn't capture it immediately. But it captures typically your hands, the objects you're looking at, other people, and the environment. And typically it is recorded from a wearable camera, so it moves with you. So the camera is typically moving, giving a significant challenge to video understanding analysis. Exocentric tends to be a very stable camera, moving very slightly. Egocentric is huge motions, huge hedge motions, but is following you as you go around the scene performing your daily tasks. Even though there are these two terms, even from an egocentric view, there are also different things you can capture. You can capture a first-person perspective, which is the person doing a task, but you can also capture a second-person perspective, so someone working with you on the task. So they can not necessarily only two pairs of hands, you might have multiple people performing together to do the same action. What ego offers is a very clear perspective on what you are working on. It's really focused on what you're focusing on. So it removes a lot of the occlusions that an exocentric camera has. It really is there, but it brings huge challenges because you might have parts of your body, like the hand, occupying a majority of the scene. But you also have a huge head motion, quick movement from one location to the other. And that's what the ego view typically brings. So that's what people refer to as ego versus exo. In research, you tend to focus on one problem, and it's very difficult to explain to others why this is the problem that excites you more than anything else. But once you find it, it's very intriguing that you keep digging and you find exciting things. So it's really as if you're diving deep down in one spot, but discovering lots of interesting problems. I work in computer vision, but within it, there is an area called video understanding, which is significantly more challenging than images because the temporal information is bringing the knowledge. A single image doesn't tell you what someone is doing. It is the sequence or the series of images. Within video understanding, you can capture lots of things. Some people are interested in sports. Some people are interested in, capturing multiple people dancing, right? For a while, I have been observing how people do simple tasks which we naturally do. And when we try to model them, we realize they're very, very complex. Things we do extremely naturally. You get a bottle and it twists, right? You just twist and open. But if you try to model this behavior, then you realize it's not only very complex, but it's so variable between people. Different people perform exactly the same task in many different ways. And you wonder, we understand some of it naturally, like if you're holding a pen, we know that people hold pens in many ways. But this is not only for the pen. Even if you look at people opening the bottles, you realize everybody is doing it differently. And you just give a signal to someone, say, can you open this? And they know how to transform this transition of a state and object to a manner, to a behavior. But you can tell, this opening action, if I tell you open a cupboard, it's not this, right? It's a completely different action. It's a completely different behavior. But we use these terms, we call them verbs of state. So how you want to change the state of the world. And mapping this to behavior, to manner, is such a complicated process that, it's very difficult to do. And even if you say, oh, I know that cupboards and bottles are opened differently, even cupboards can vary in the way you can open them. So there is a strong visual signal that's transforming a goal to behavior. So for a while, I've been intrigued by this mapping that we can quickly and naturally do. And we currently can't model, not for humans, the diversity in which how humans do things, and we cannot map this to potential robotics. Recently, we were looking at footage and seeing that hands sometimes manipulate 3 objects in one go. You're like opening something and throwing something while you're holding something else. And we haven't even touched this. We still talk about 2 hands, 2 actions. The truth is 2 hands, maybe 10 actions. So if you look at the footage and you try to analyze it to what we call fine-grained understanding, we're very far, despite the presence of the deep learning technology, from achieving this understanding. We were looking at people breaking eggs and saying, you hold something, it's called an egg, but the moment you break it, what comes out of it is what you call an egg. And what's in your hand is now a shell that you want to discard, right? So if you look at the actual, what you call the pixels in the image over time, they change the semantics. They change the relevance to your goal. Once I break the egg, I don't care where these shells go. I'd rather put them in the bin, but I'm not interested in understanding them. And then even objects have different states. We talked about the egg. So you have the egg before you break it, the egg after it's ready, the egg pre-cooked. And so objects even change semantics over time. Language is very difficult to understand the complexity of, like, a picture is worth 1,000 words. It's become so clear in video. Like, a video is like 1,000,000 words as people perform tasks very differently. So I'm intrigued. I find that such an interesting problem. And I find that I've only tackled, despite being in research for more than 15 years, a very small part of it, that I feel it's something that can fill the remainder of my research years. Not only that, I'm so proud of the students in the lab that are also bringing this and introducing new problems and new questions and building research around this full understanding of how people transform and change the world. I find that very strong. Humans go around doing simple things that they think are natural, but they're in fact changing the status of the environment around them. They're practically changing the world. And if we can model this, a human changing the world, then, that's such a strong research question. But I always say researchers are always interested about strange things. I still can't get my parents as excited about this topic, despite explaining to them many times. So I understand if the viewers can't understand the excitement I have. The next 10 years of egocentric research is very exciting because people are starting to imagine these devices actually in use by everyone. So the ability to move from handheld devices, mobile phones, into wearable devices that are still allowing you to remain connected with the world, do everything you wish to do on these handheld devices, but having your hands free again to perform tasks. So imagine what we currently are doing. We're trying to remain connected, but we want to do things. And sometimes we cut on what we want to do because we want to remain connected. So now we have our hands free. We can go perform all the tasks we wish to do, but also remain capturing what people are doing, helping them do things better, connecting them to others doing similar tasks in different locations, collaborative understanding, multiple people performing the task, synchronized recordings of multiple people doing the tasks, understanding how people interact towards better interaction or human-robot interaction. These are my ideas, but actually once these devices are with people, there are many people who will come up with even further imaginations. What's happening is that these devices are becoming a reality. They were in people's visions for many years, and now we can see them, we can use them, we can give them to more people, we can record more footage with them. And that's what Aria is enabling, is that, we have tens of these devices now, when each lab maybe had a single, ad hoc setup that broke after a month and we were not able to keep up with. Now we have something that is reliable, so we will be able to do more and capture more. What will the footage enable is, I think, a very big question, but we know a few things, like it will enable you to do, to know how people move around their environment, how people change environments, and how that change changes over time, how behavior adapts. And that's the potential big question. How do people change their behavior over time? It's not a snapshot of you, it's actually a continuous capture of your behavior. The favorite part of my job is when I have a new student, having been in the area for 15 years, who after a month or two brings up a question I don't know how to answer. When they say, as just mentioned I just mentioned an example of a student who showed me the hand doing 3 actions at the same time. I did not think this was feasible, and they do that by just looking at the footage and bringing fresh ideas. Being in universities, you have new, fresh ideas coming every day that keeps you fresh, keeps you on your toes, because you can't relax and say, I know everything. They always bring new ideas, they always bring new insights. And every time a new student brings something new, I'm like, wow, I still have a lot to learn, and learning with them, and also improving for them so that we are a better group, and they then graduate and you see them becoming independent researchers on their own right. I think that's definitely the favorite part of my job.